Today we want to talk about the binomial distribution. Binomial distribution is one of the most useful distribution for good reason. It describes a certain discrete random variable, and it is applicable to many situations. And you are going to see soon why it is applicable to so many situations. Now we are going to look at the scenario that is close to our 8th problem. Remember, in lesson 3, we gave an example that we have 8 eggs to a rotten. Okay? And there you can see that with and without replacement have very different results. Today we are going to look at another scenario. We have 8,000 eggs from a farm, and 2,000 of those are rotten. From these 8,000 eggs, we are going to pick 2 out, and we want to compute the probability that both eggs picked out are rotten. So if we write things formally, we can say n equal to 8,000. N is usually used to represent the population size. Well, out of 8,000 eggs, 2,000 are rotten. And we are going to pick a sample of 2 out. We use small n to represent the sample size. So here, the sample size is equal to 2. And we also want to formally represent what are we interested in, the variable of interest. We use x to denote it. And x, the variable that we are interested in, is the number of rotten eggs in the sample of 2 eggs. Okay? So you can see that this x is a random variable. Depends on our luck, right? And x can be 0. There's no rotten egg out of these 2 samples. X can be 1. 1 rotten egg out of these 2 samples. X can also be 2. You are so unlucky that the 2 eggs you sample both are rotten. So let us see what is the probability. We are so unlucky. And let us look at those 2 situations depending on how we sample, right? We remember we can sample with replacement, and we can also sample without replacement. Let us first look at sample with replacement. So we are computing probability x, number of rotten eggs out of the 2 eggs, x equal to 2. And that probability is equal to, for the first pick, it is 2,000 out of 8,000. And, well, being with replacement, life is easy. We put it back. Whatever we pick, we put it back. So for the second pick, it is still 2,000 out of 8,000, right? We put it back. We still have 8,000 eggs, and we have 2,000 that are rotten. So the answer is 1/4 times 1/4. And we have 0.0625. And what about without replacement? Without replacement, then probability x equal to 2 would be equal to, for the first pick, it is 2,000 out of 8,000. And for the second pick, okay, so we know that the first is rotten egg. many do we have? 1999. So we now have 1999. Okay? How many x are there? 7999. So we compute that, and just looking at it, you know that this answer won't be too much far off, because this is pretty much close to that. And I use my calculator. The answer is 0.0624765. And you can see that these two answers are very close to each other. And this demonstrates what? This demonstrates that when our sample size, small n, is small compared to the population size, the capital N, then whether you use sample with replacement or without replacement does not matter. And we may as well use whichever is simpler. And the simpler one is this one. So, in real situations, quite often, we will just say the two events are independent. For convenience, we can compute the probability easier. And so, in the case that we sample with replacement, or when the sample size is small compared to the population size, we have binomial distribution. What has the binomial distribution? This thing, x, has binomial distribution. What is x? X is the successful event, okay? X is the number of successful events. What is successful in our example? Turns out rotten egg is the successful event. So the total number of rotten eggs you get out of two trials. That x has a binomial distribution. And we know that this distribution depends on small n. Okay? How many samples do you take? Trial. In binomial distribution, it is the number of trials. So, another location is this n is in binomial is equal to number of trials. We pick x 2 times. So, number of trials in this case is also 2. So, you can see that similarly, we can ask this type of question. Assuming we have this scenario, things has a binomial distribution. And we can compute probability x equal to 0 as well, right? What is probability for a good x? And we can also compute probability x equal to 1. Okay, out of the 2x, what is probability? 1 is rotten. We can also compute probability x equal to 2 as what we did.